So the next plot which we have to focus in Bode plot is plotting phase angle plot. So we already know g of j omega into h of j omega is this expression 10 divided by j omega into 1 plus 0.4 j omega into 1 plus 0.1 j omega. The first term, we'll consider the first term by term. Let us consider the first term which we had considered was 10 divided by j omega. To find out angle, always we'll use a formula called as tan inverse of b divided by a for complex number. For example, if we have a complex number such as a plus ib in a plus ib form, to find its angle, we'll be using this formula tan inverse of b by a. So let us convert this term into complex number. We have a real term 10 plus 0 j omega divided by real term, the denominator is 0 plus the imaginary term is j omega. So if we plot, if we observe what will be the phase angle for this, tan inverse of b term here is 0. So 0 divided by a term is 10. 0 by 10 is anyhow 0. So divided by the bottom angle, the denominator angle. So tan inverse of j omega. The b term which we have here is omega. So omega divided by a term is 0. Here in the numerator 0 into omega. The b term which we have is 0 omega. So 0 into omega is in here 0. So what we get here is tan inverse of 0 by anything. 0 by anything is in how 0. Tan inverse of 0 divided by tan inverse of anything by in 0 is infinity. So tan inverse of 0 is in half 0 degrees divided by tan inverse of infinity. Tan inverse of infinity is always 90 degrees. So whenever this 90 degrees is shifted towards the numerator, what happens is the angle which we get for this particular term, the angle which we get will be equal to 0 degrees minus of this angle. If it goes to the top, it becomes 0 minus 90 degrees, which will be equal to minus 90 degrees. So for the first term, the angle which we get is minus 90 degrees. So don't get confused why we have taken this division and 0 divided by 90 degrees, how it will become minus 90. Whenever the angle goes towards a numerator, whenever denominator angle goes to the numerator, the sign gets changed. This is the basic. For the next term which we have is 1 divided by 1 plus 0.4 into j omega. So let us convert this into complex number. So this will be equal to 1 plus 0 j omega divided by 1 plus 0.4 into j omega, which is anyhow in a complex form. So if we apply this formula, tan inverse of b by a, we'll get as tan inverse of 0 omega. 0 omega is anyhow 0 divided by a value is 1 divided by tan inverse of 0.4. In place of b we have 0.4 omega. 0.4 omega divided by, in place of a we have 1. So this will be equal to tan inverse of 0 again divided by tan inverse of 0.4 omega. So tan inverse of 0 is in here 0 degrees divided by tan inverse of 0.4 omega. So when this is sent towards the top, the angle with respect to the second term will be equal to 0 minus tan inverse of 0.4 omega. Hence, the angle of the second term will be equal to minus tan inverse of 0.4 omega. So this is the angle which we have to solve for. Next, similarly, let us consider term 3. So with respect to term 3, the term 3 which we have is 1 plus 0.1 into j omega, which can be written as 1, can be written in the complex form as 1 plus 0 j omega divided by 1 plus 0.1 j omega. So if we use this formula tan inverse of b by a, in place of b we have 0 omega divided by, in place of a we have 1 divided by, again tan inverse of b by a, 0.1 omega is the b value which we have at the denominator side, divided by a value is 1. So this will be equal to tan inverse of 0. 0 by anything is 0. Hence we have written tan inverse of 0 divided by tan inverse of 0.1 omega. Tan inverse of 0 is 0 degrees divided by tan inverse of 0.1 omega. Again, when this angle is shifted towards the top, because we have 0 there, the angle with respect to the third term will be equal to 0 degrees minus, when this angle goes to the top, it becomes minus. We have to take opposite sign, tan inverse of 0.1 omega. So the angle which we have to focus upon is, for the third term, is minus tan inverse of 0.1 omega. So the total phase angle with respect to the complete term will be equal to summation of the individual phase angle terms which we have got. For the first term we have got one phase angle, for the second term we have got one certain phase angle, similarly for the third term we have got certain phase angle. So the summation of all these phase angles will give us the total phase angle of the given expression. So the total phase angle will be equal to minus 90, which is the phase angle for the first term. Next term 2 summation, next summation of term 2 phase angle minus tan inverse of 0.4 omega minus tan inverse of 0.1 omega. The summation of individual term phase angles, whatever we have got, that will be the total phase angle. So this expression is the expression for the total phase angle for this particular expression. So to get the values for different values of omega, to get the value of angle for different values of omega, what we do is we'll substitute different values of omega in this expression to get some values of phi. Those values, whatever we get, that will be plotted in our semi-log graph sheet. So first let us consider the lowest frequency which we have considered is 0.1 radians per second. So we can use calculator for that. Instead of substituting manually, what we can use the help of calculator. So in calculator we have we can input the value which we have got here, the expression which we have got here, minus 90 minus tan inverse of, open the bracket, 0.4. We don't have omega in our calculator, so in place of omega substitute as a. So press alpha and this minus in the bracket, whatever we have, that button if you press, we'll get a, close the bracket, minus tan inverse of, open the bracket, 0.1. Again we don't have omega, in place of omega we'll substitute as a, alpha, minus in the bracket, close the bracket. Okay, and after this don't press equals. After this what we have to do is press calculate. It will ask you to input the value of a. Here a is nothing but omega. So the a value which we are considering here is 0.1. So press 0.1 and press equals. It will give us the value. So the value here is minus 92.86 degrees. Approximate it to minus 93 degrees. Approximately minus 93 degrees. Similarly we can consider for the next values. Next let us consider for omega is equal to 0.5. So for omega is equal to 0.5, what will happen? So after this again to check for the value for omega is equal to 0.5, don't press equals, go for calculate option again. It will ask you to input the value, the second value of omega, 0.5, press equals, it will give us the value. So the value which I have got is minus 104.17 degrees. Let me approximate it to minus 104 degrees. So like this we can continue and we can get the different values for different values of omega. So what we have done here is for different values of omega we have calculated what is the angle, value of phase angle. So for 0.1 we have got minus 93, for 0.5 omega we have got minus 104, for 2.5 we have got minus 150, like that. For 20 radians per second we have got minus 236 degrees. So these values whatever we have got will be plotted on semi-log graph sheet to get phase plot.